All right, let's talk about a problem that every single developer feels in their bones. You push the new code, everything looks fine, and then, somewhere in that huge, complex web of services, things just get weird or slow. Today, we're going to flip on the lights and demystify observability so you can finally stop debugging in the dark.
So, here's our game plan. We'll kick things off with the modern system mystery. Basically, why our old tools are failing us. Then, we'll introduce the famous 3 pillars, which is your new toolkit. After that, we get really practical. We'll look at how to create powerful signals, build alerts that are actually smart, and then, the best part, connect all those dots to solve problems way, way faster. Okay, so let's set the scene. You've built this amazing modern application with microservices, the whole shebang. But whenever something goes wrong, it feels less like an engineering problem and more like a detective novel where all the clues have been ripped out. So why is that? What makes these systems so hard to figure out? This right here, this is the question. It's not about a simple is it up or is it down anymore. We need to understand why the system is acting the way it is in this exact moment across maybe dozens of different services that are all talking to each other. And this is precisely where the old monitoring playbook just completely falls apart. Think about it. The old world of monitoring was built for a simple question. Is the server on? You know, a green light or a red light. But in a distributed system, that question is almost useless. A single click from a user might travel through 10 different services. The system is never really up or down. It's always in some state of partial health. And we have to understand the messy reality of that. And this creates, honestly, a perfect storm of problems. A request takes this long, winding road through your system. A failure isn't some big, loud crash. No, it's a subtle slowdown that's super frustrating to pin down. You can almost never reproduce it on your own laptop. And the worst part? Your users become your first line of defense, telling you something's broken before your own dashboards have a clue. To solve these new kinds of mysteries, we need a totally new way of thinking. And that's where observability comes in. It's a huge shift. It's about instrumenting your system to produce data that's so rich you can ask questions you never even thought of before, and get answers without having to ship a single new line of code. It basically turns you from a victim of all this complexity into a detective who has all the clues right there. So, how do we actually build this detective's toolkit? Well, it all starts with 3 fundamental types of data. People often call these the 3 pillars of observability. Let's break them down. First up, you've got metrics. The easiest way to think about these as the vital signs of your system. You know, the heartbeat, the blood pressure, they're numbers like CPU usage or average latency collected over time. They are fantastic for telling you what is happening at a high level. You can easily spot a spike or a dip or some new trend. Okay, next up, logs. So if metrics are the vital signs, then logs are like the system's super detailed diary. Every log is a specific, timestamped record of a single event. They give you all the rich context you need to answer why something happened. The metric told you latency spiked. The log is what tells you it was because of a database connection timing out. And the third pillar is traces. Now, traces are basically the GPS map for one single request. A trace shows you the exact path a request took through all your different services, and critically, how much time it spent at each stop. So when that latency metric spikes, traces are what answer the all-important question, where is the slowdown? Which service is the culprit? And here's the real magic. They're not 3 separate things. They all work together. When a user sends a request, it hits service A, which spits out its own logs, metrics, and trace data. Then it calls service B, which does the same thing. Then service C. You get the idea. For every single request, you get this complete, multi-layered story from the very beginning to the very end. So we've got our 3 pillars, but look, their power is 100% dependent on the quality of the data we're feeding them. You know the saying, garbage in, garbage out. Let's zoom in on logging for a second to see what a huge difference this makes. I mean, this comparison says it all, right? On the left, you've got a log message that, let's be honest, we've all written out of frustration. Something failed. It's completely useless. But on the right, now that is a clue. It's a structured, machine-readable log. It tells you the service, it gives you a request ID so you can connect it to everything else, and it gives you a specific error. The left is just noise. The right is a signal. So how do we get those good logs? It really comes down to a few simple rules. First, always use a structured format like JSON so machines can actually read it. This is so important. Always include a correlation ID, like a request ID. That little ID is the golden thread that lets you tie a whole user journey together. Use log levels so you can filter out the noise. And super important from a security standpoint, never ever log secrets or personally identifiable information. All right, so we're collecting all this great, high-quality data. Now let's talk about how to use it in a smart way. The goal isn't just to find problems we already expect. It's to find those unknown unknowns, the issues we didn't even know we should be looking for. We've all fallen into this trap, right? You set up a static alert threshold, something like, hey, ping me if latency goes above 500 milliseconds. The problem is, normal is constantly changing. 500 milliseconds might be a total catastrophe in the middle of the night, but it could be perfectly fine during your Black Friday peak. Static alerts just create noise. So instead of using a dumb static number, we need algorithms that can actually learn our system's natural rhythm. A classic one for this is the Holt-Winters algorithm. It's smart enough to understand things like seasonality. The fact that your traffic on a Tuesday at 9 a.m. looks totally different from a Saturday at midnight. It models these patterns to predict what the metric should be, giving us a dynamic, intelligent baseline for normal. Let's see what that actually looks like. Imagine your old static alert is set at 500 milliseconds. At 9 a.m., your latency hits 400 ms. Your static alert does nothing. It stays silent. But an algorithm like Holt-Winters knows that for this time of day, latency is usually only around 120 ms. So that 400 ms spike is a huge deviation from the expected pattern. That's a real anomaly. That's an alert that actually means something. Okay, this is where it all comes together. We've got high-quality signals coming from our 3 pillars, and we've got smart alerting that can detect real anomalies. Now, let's connect all those dots and see how this creates a debugging workflow that is just incredibly fast. So picture this. An alert fires. Boom. Latency has spiked. That's your what. You immediately jump over to the traces from that exact moment, and instantly you see it. All the slow requests are getting stuck waiting on the payment service. That's your where. So you pivot one more time to the logs for just the payment service, and you filter by the request ID from one of those slow traces, and there it is, plain as day, a whole stream of payment timeout errors. That's your why. What, where, why. You just went from alert to root cause in minutes, not hours or days. Now, to make this work, you can't just monitor everything under the sun. You'll drown in data. You have to focus. And this is where the golden signals, an idea from Google, are so brilliant. There are 4 key metrics that tell you the most about what your users are actually experiencing. Latency, how long are people waiting? Traffic, how much load is on the system? Errors, how many requests are failing? And saturation, how close is the system to its limit? If you watch these 4, you'll have a really solid pulse on your system's health. We've covered a ton of ground here, from the big ideas down to the nitty-gritty details. So the big question is, how do you actually get started with all this? Let's make it super practical. Here is your call to action, your 4-step plan. And the most important advice I can give you is to start small. Don't try to boil the ocean. Just pick one service. Step 1, get structured logs working in that service and make sure you have that request ID. Step 2, define its golden signals and get them on a dashboard. 3, find your noisiest, most annoying static alert for that service and replace it with one smart, baseline-based alert. And finally, step 4, just practice. The next time there's a problem, force yourself to use this what, where, why workflow. And that really brings us to the core of it all. Observability isn't really a set of tools you buy, it's a capability you build. It's the power to ask any question about your complex system and actually get an answer. So the thought I want to leave you with is this. Now that you have this power, what's the first question you're going to ask? What mystery will you solve first?